This is the Eco Innovators podcast, your go-to source for the Canadian energy and natural resource nexus. I'm your host, Stewart Muir. In this series, we're talking to the people turning today's challenges into tomorrow's solutions. Ian MacGregor, my guest today. Welcome, Ian.
Thanks for having me.
It's great to see you. You're the executive chairman of Hydrogen Naturally. I know you've been on the scene for decades, building all kinds of big stuff, like the Sturgeon Refinery project. What was the price tag on that one? How big was it?
It was just over $11 billion.
11 billion
finished,
in Edmonton.
Yeah.
And then you also did the Alberta Carbon Trunk Line.
Yeah, that was about $1.2 billion or $1.3 billion by the time we were done.
The world's largest operational system for capturing and storing man-made CO2.
I think it is, yeah.
Yep, and it's connected to the refinery. That system, it began operations just 2 years ago, and it's already transported and stored about 3 million tons of CO2.
Yeah, I think we're up to 4 now.
Four now,
actually.
okay, wow. And you're working on a new business.
Yeah, so I'm working, we learned a lot about the hydrogen business when we built the refinery, and so we think we're experts in the making of hydrogen now, and we've got a new idea about how to make it.
And this is the carbon removal and green hydrogen hub concept.
Yeah, really we're trying to take carbon out of the air and put it underground, and we get hydrogen when we do that.
And you're going to do that in Edmonton as well?
We are, yeah.
Okay. Yeah. Ian, I've known you since at least 2016. We go back a long ways, and there's an incredible story. I don't know how many people know this is associated with your name or even know about the Canadian Museum of Making. I've visited it a couple of times, and every time it just leaves me gobsmacked with how amazing a vision it is. And it's your vision. Tell us a little about where it is and what the purpose is, and also how it connects your work today to your interest in engineering. So what is the Canadian Museum of Making?
So I try and collect, I try and save things that I think should be saved. That the next stop besides me is the scrap dealer where they end up being melted down, so we lose them forever. And
you have a working steam engine.
Yeah. So
in your basement.
Yeah,
sort of.
Yeah, it's where I hide it from my wife.
But I think you need to describe it just to give people a picture, because you roll up to the ranch in Cochrane, and it goes back in your family to the 1970s. Yeah. It looks like any other ranch, really. There's a smithy, there's a barn, there's a few outbuildings, and there's a beautiful old ranch house, right? Yeah. But then you go inside and down the stairs, and what does one find?
Yeah, so I built everything underground there because we were starting to get quite a few buildings. Right. And I thought you can't improve the looks of the place by building more buildings. The way you can improve the looks of it is to leave it alone. And so I decided I had to, anything else I was going to do, I probably ended up doing underground. And so I've been acquiring stuff since I was a kid. And so I'm 73 now. They can't see me, but I'm 73. So I've been acquiring a lot of stuff. And I retired, I guess probably, 20 years ago was the last time I retired. And when I retired, I decided I had all this stuff, and I thought I should get the important things fixed up and on display. And so we tried to figure out how we could do that underground. So we dug a giant hole and poured concrete in it and ended up with a place underground there where we can display all these artifacts. So I guess the biggest of the artifacts is a steam engine. It's about a 60-ton engine. I brought it over from near Halifax in England. And, I went on holidays one year to take it apart, and then we brought it back and set it up outside first to try and figure out the proportions of the room. I'm not a good enough architect to tell what a room looks like from a drawing, so I have to mock it up in full scale before I know. So that's what I did. We mocked it up. We adjusted it till we thought it's going to feel like an engine room when we're in there, and then we built it. So that's what we did.
Yeah, it's hard to convey the full impression. I mean, this has many of the attributes of a nation-class museum. It is built to the highest standard. The artifacts you have and the curation of them, the ordering of them through the journey as you go along is the result of an incredible amount of thought. Did you do all that yourself, that work to tell the story?
I worked with experts all the way through, but I have a pretty, I would say, when I do something, I have a pretty granular idea about what I want it to look like when I'm finished, and I enjoy the process of trying to figure that out. So I work with the best experts I can find in the areas that I'm working in, and together between us, we jointly do what neither of us could do alone. And I don't start if the budget is limited. I can't think about the budget when I'm doing it because we're trying to do it, we're building the pyramids. They didn't care what the pyramids cost.
That's right. All right. Well, I'd love to do a whole show about the Canadian Museum of Making because it just is an extraordinary experience. Can people go there, by the way?
We have a few open days a year. It's always open to kids. So we always try and get kids there because we think some kids are like me. They're not going to be people that play soccer. They're going to be taking apart something. So those kind of kids are always, well, any kind of kids welcome there, but generally kids that are on the nerdy end of the spectrum end up there somehow. And the other thing we do is we have anybody who's got a car club comes. So we want enthusiasts. We want people that have passion about what they do, and that's who it's open to.
Well, I'm sure they find you. Now, why we're here today, Ian, is to talk about your new hydrogen project. That's Hydrogen Naturally.
Yeah.
And let's start with the idea phase. What inspired you to start this project?
So first thing I'll say is, sorry, I'm just going to do something here. So when I work on something, I don't think there are any really great ideas. I haven't seen that in my life. What I think is there's okay ideas in good hands. And so this is another one of them. And when we built a refinery up in Redwater in Alberta, and inside that refinery was the world's largest blue hydrogen plant. And when we built it, we didn't know it was a blue hydrogen plant. We just thought it was a hydrogen plant. But we were capturing the CO2, and that turned out to be what they call blue now. And so when we do something like this, it's an evolutionary approach. We understand that it's it's mind-numbingly complex when we start. And so when we solve the problem, we expect that it's going to grow almost in an organic way, and we're going to have to figure it out. And so, the main thing for me that I try and get across is we don't start with a great idea. We start with a great team of people that can take on uncertainty, and they figure out how to solve problems and adapt to them as they come. And then we're careful. We don't take it. If someone on the team doesn't understand the problem and it isn't an expert in it, then we probably won't take it on.
There was an article in Harvard Business Review we were talking about before the show started, which gets into this a little bit. What do you think the key idea is there?
I think the key idea is, some people look like they're lucky. And they are, but the reason that they're lucky is they don't let failure poison the well of inquisitiveness. And so they keep trying no matter what happens, no matter how many times they fail, they learn from their failures, but they don't get grumpy because of them. They get inspired because of them.
Now your focus is on natural air capture, NAC. And that's in that whole bucket of carbon capture, right? Because you're capturing carbon from the atmosphere.
Yeah.
So let's get into a little of what that means, because there's a few steps we'll have to go to, because I think if we can leave our listener with a whole idea of what this is all about and how it fits in, maybe some of the challenges as to adopting it on the scale. I mean, you've built $12 billion projects. How do we turn this idea into something that's big and successful over the long term? So natural air capture, what is it?
So people have been talking about what's been happening is we've been putting CO2 into the air for a long time now through combustion. So we filled up the bathtub. You could think of it, we filled up the bathtub. We're about an inch from the top. We're going to overflow. There's nothing we can do to stop overflowing except take CO2 out. And some really smart guys.
You're talking about climate change here.
Yeah. So people have talked about, to hit the 2052 degree goal, we're going to have to take CO2 out of the atmosphere. And we can't stop soon enough. We'll melt down the economy if we stopped. You couldn't drive your car anymore if we had to stop. We'd have to stop tomorrow morning. We'd have to start driving our cars if we were going to hit that. So I don't think that's going to happen, and it's certainly not going to happen in the poor parts of the world. And so what we have to do is figure out a way to take it out. Some really smart guys, there's all kinds of chemical ways you can do that. But when you take a glass of wine and you pour it in the bathtub, that's what you're trying to recover, at 400 parts per million, the concentration of CO2 in the atmosphere. So we start thinking about it, and we're engineers. We don't, we can't think the high science thoughts. We can just think of how do you do this. So what we thought is, well, there's a machine that's already been doing that. It's been around for 250 million years. It takes the 400 parts per million, or sometimes 300 parts per million in the air, and it concentrates it up to 500,000 parts per million in the tree. And we're, in Canada.
That machine is a tree.
It's a tree, sorry. So the trees are doing that. They figured out how to do it, and they figured out how to do it with solar energy, and they figured out how to do it with the water that's in the environment. They don't need to be watered to make them grow. So we say that's, if you're looking around for mines, usually what you do is you start with the biggest mine you can with the most concentrated ore in. And so we don't think that is the atmosphere. We think that's the worst ore you can get for your mine. So what we decided is, well, the tree's making a pretty good concentration effort. We ought to be able to take advantage of that. And when we built the refinery, the heart of the process is something called a gasifier that essentially converts carbon into pure CO2 and hydrogen. And the reason the CO2 has to be pure is you can't sequester it unless it is pure. You have to get it into a liquid form before you can sequester it. So if there's nitrogen in it, you can't afford to deal with it. You got to get the nitrogen out. And so what the gasifier makes in our process is pure CO2. It doesn't have any nitrogen in it, and then we can sequester it cheaply. And what I just described there, the difference between 60% purity CO2 and 100% purity is about $70 a ton, which is an enormous amount of money that you'd have to spend to clean it up. So we don't have to do that.
Just to get a mental picture here, Ian, of how the forest waste products get from being in the forest to being at the hub turned into hydrogen.
Yeah.
What's the journey?
So the journey starts with you have sort of three kinds of, when you think of the forest, I've got trees that I make into lumber. We don't touch those. But there's all the stuff that's left over from the lumber making stuff. So there's the sawdust, the slabs, the branches, the tops, the bottoms, all that stuff ends up being taken to a pelletizing place, and we pelletize it. And the reason for pelletizing it close to where it's harvested is the trees have water, or the wood fibers have water when it starts off. So you have to dry that. Otherwise, you're moving half water around, and you don't.
That's
need
expensive.
To do that. Yeah, that's expensive. So first step is collect what's there. There's kind of three types of it. There's the stuff that I traditionally leave in the forest floor, really low value stuff, can't afford to haul it to the thing. But remember, we're selling carbon, we're not selling paper. So when you look at this stuff, you have to think of the value of carbon, and our economics are different and more margin than everybody else's are from what we can see. So we think we'll reach further back into the forest. We think the best use of the scrap stuff will be to make pellets and send them to us. That'll create more margin for the owner of the pellets. And then finally, we think we can compete with the pulp market at some point. And so we think some portion of stuff, if you had a pulp mill and you can't afford to rebuild it, maybe this isn't such a bad alternative market for it, because we think there's more margin in our stack than there is in any one of the other ones.
Let's just step back a little bit here
Okay.
and look at the whole category of CCUS,
Yeah.
because it seems like NAC fits in there, right?
Yeah.
Carbon capture,
Yeah.
utilization, and storage.
Yeah.
And right now in Canada, we're seeing all kinds of investment. So CCUS, we are seeing in Saskatchewan with the Boundary Dam, they've been sequestering carbon. And then in Edmonton, you've got your carbon trunk line
Yeah.
that you built.
So we built it, yeah, it takes CO2 from nutrient, and
Right.
those are the only pure sources of CO2. That's all the pure CO2 that is in that part of the world right now.
Right.
So Shell has a project called Quest.
yeah.
They cleaned up a reformer stream, which was 60% purity, and they handle it just for themselves. Our system eventually ended up being owned by a derivative of Canada Pension Plan called Wolf Carbon Solutions. Right. So they own it now. And we designed it as an open access system. So anybody could put CO2 on and anybody could take CO2 off.
Right. And you can also point to the Pathways initiative that the oil sands operators are doing to move CO2 to permanent storage underground.
Yeah.
And then we've got companies like Carbon Engineering that came out of UBC in Vancouver, and that is DAC, direct air capture. So it sounds a little bit closer in terminology terms to natural air capture.
Yeah, I mean, I think what we're doing is really close to them, but what we bring is sort of the missing part of the equation. And we've done lots of carbon sequestration. So my office has been involved as either an inventor, a founder, or a financier. So there's only 3 people in my office, so I don't want to make it sound like some grand thing. There's 3 of us there, but we're good engineers. We've done 10% of the world's CO2 sequestration. So it's not, and we've done stuff. We're not in the world of I'm announcing something that I'm going to do. It's stuff where we've actually got CO2 flowing through a pipe and going underground. So we've done 10% of the stuff that's been done in the world.
Mm-hmm. Now, that's the technology. Let's shift over a little bit to the policy side, because in Canada, in British Columbia, you've got these standards for what refineries have to do when they produce the fuel, the gasoline, the diesel that goes into the vehicles we drive. Yeah. And the Canadian one is a low carbon fuel standard. Yeah. BC has got its own one. And those apply to how refineries operate. You know a lot about refineries. How does a low carbon fuel standard enable or not enable what you're trying to do?
So I think it enables it, and I think over time, logic always prevails in these things, and sometimes when they start, full logic isn't operational. So I'll use the analogy of wind to sort of try and translate into the refining business. So if you thought of having a wind farm and you thought every wind farm has to be directly connected to the place where the electricity is used, there wouldn't be very many wind farms because it would be really hard to directly connect them. So what I do is I make an electron with wind, I put it on the utility system, and it comes out wherever I say it comes out. That's not the electron that I made in the wind energy. It's just they got mixed together, but I've streamed that electron and only given the benefits to where it comes out. In the refining business, that isn't true. The refining business right today is it's all got to be physical. And so when I make something in Alberta, I got to be able to trace the molecule through to where it comes out of the pump here. And that makes it a lot more difficult than it needs to be. And my own opinion is that will go away in the fullness of time, but it's not gone away yet.
Mm-hmm. So if you look at what they're doing in British Columbia, recently there was a project by Parkland, which has the Burnaby refinery. They were going to create a biodiesel line there, or a new process. But then a few weeks ago, they said, "Oh, we're not going to do this." And one of the things they cited was the Biden administration's measures, which seem to have attracted that investment south of the border. Do you think that's a major influence on that decision to cancel that project?
I think if you overlay that on the required physicality of it, I think it might be. I think Canada's a very good place to do this, and we're doing something that's different than what they were doing. What they were doing is taking a vegetable oil and hydrotreating that vegetable oil and making it into a diesel replacement.
Now, we should want more investments like that in Canada. Agreed?
Yeah, I mean, but what I think we should do is, in Canada, we should work down what is the most economic thing to do first, because we can do most of it and we can do it quickest.
Help me try to figure something out here, because I've been trying to figure out the low carbon fuel standard as it applies in British Columbia. What they're trying to do is put in products that are lower carbon into the blend. Right, and that's how you lower the emissions.
Yeah, there's a carbon intensity number that you're trying to hit, and petroleum-based diesel has a certain carbon intensity, and then I can buy down that carbon intensity by blending it with lower carbon intensity materials.
Now, what materials are available to do that blending with?
Well, Canada's a special place, and it gets cold here. And so biodiesel that's made with a simple process turns into a solid at around minus 35. So you can't have that in your diesel pool in winter. So you can take that same material and run it through a special kind of refinery and hydrotreat it, and then it has the pore characteristics that you need. So that's what's being bought right now, and that mostly comes from Singapore. It's called HDR.
From Singapore, from the other side of the Pacific.
Yeah.
But we're one of the world's biggest producers of oil and gas, forestry products. Surely a country like Canada doesn't have to get that kind of material from Singapore.
And we've been, this is a part of telling you how rather than telling you what. And so how right now is we're focused on blending. We blend down to get carbon intensity. We could put the molecule in the front end of the refinery, and that molecule will go through the refining process. So we could put the hydrogen made from trees in the front end and buy down the carbon intensity in the same way, actually a lot cheaper though, because we don't have to ship it all over the place and we don't pay the Singaporeans to refine it. So we can do that here, but so far no one's been doing it. So we have to, that's part of my job, is to convince people that makes sense. But to me, it's the best thing we can do, because we can take money that we're sending outside the country. Where does that money show up? It shows up in jobs in Fort Nelson. It's like, is there a better world than that?
Yeah, that makes a lot more sense. If you're successful with your idea, what's the number one benefit?
So, two benefits. We extract the CO2 from the air. Everybody, I think, is believing that is
That's
something
a good
we're
thing.
going to have to do. And who's going to do it cheapest? And it's not just cheapest. I have to do it cheap, I have to do it big, and I have to do it fast. And so usually those three things can't live together. You get one, you can have any two of the above. But, excuse me, I just need more coffee.
All right, Ian. So what's the prime reason, or top couple of reasons, why we should support Knack?
So the reason you should support it is we're taking CO2 out of the air. The tree takes it out. We take the tree and recover the carbon in the tree and put that underground. So that's a good thing to do. And if we don't do that, the tree rots or gets burned, or it goes back into the environment in some way. So what we're doing doesn't allow that CO2 to return. So the tree's doing a valuable job that would be expensive if we tried to get a machine to do it, and it would be energy consumptive as well. The second thing we do is we make hydrogen. And the hydrogen can go at the start of the refining process, not at the end. If we put it in the start of the refining process, we reduce the carbon intensity of the diesel that comes out, and it's normal diesel. It can go everywhere. We don't need to build a new service station that can sell hydrogen. We just have to sell the diesel we're selling. And in this interim phase, everybody, you know, there's a nirvana out there where we're not using carbon anymore. I'm going to be dead when that happens. What we can do is we can easily convert the diesel we make to have a lower carbon intensity, and that's the first and easiest step, and we can do a lot of it without doing anything else.
When you look at hydrogen as a molecule, it's one of the most important industrial gases we have, but it's not something the average person thinks about. It's just in the background. When you talk about hydrogen in the refinery, what is the job that hydrogen does?
So in the refinery, when you get oil out of the ground, it's a long chain molecule. And so when I put it in a refinery, I chop it up into small pieces. And if I don't put hydrogen on the ends of those pieces, they all glom back together and I can't do anything with it. So part of making something that we can burn in our cars is having hydrogen on the ends of it. So a refinery like ours has a really big hydrogen plant in it. It's 150 million standard cubic feet a day.
Okay, so you got hydrogen used in the refining process, and then you got hydrogen as a product. I hear all kinds of uses, whether it's in vehicles, whether it's in natural gas mixed in with hydrogen going to the house. What do you think, Ian, are the predominant future uses of hydrogen as a low carbon or no carbon fuel?
What I think is 95% of the hydrogen made in the world is used for refining or fertilizer. And I think 50 years from now, 90% of the world will be using hydrogen for those purposes. We talk about all these other ones, but hydrogen is a really expensive molecule to make. When we make it with everything but electrolysis, we make enormous quantities of CO2. So when I make a molecule of hydrogen, I make a molecule of CO2 at the same time. And that's getting more expensive, not less. And so what I think is we're going to keep using it for things we have to use it for. So when we make ammonia, we don't have any choice. We got to add hydrogen and nitrogen to make ammonia. When we refine oil, the only way we can make it burnable in the kind of machines that we make today is it's got to have hydrogen in it. And that's going to continue to be the predominant uses, I believe. Mm-hmm. Certainly for my life.
Right.
Yeah.
Now that hydrogen in future, probably a lot of it is going to be blue hydrogen, which means hydrogen made from natural gas where the carbon is captured and sequestered.
Right, yeah.
So that's a good product for the climate, I would say.
Yeah.
Okay, and then what color is Knack? I know there's all this talk about the many different colors.
Yeah, so we trademarked it. We called ourselves Bright Green.
Bright Green,
because we retain the carbon capturing attributes of the tree in the hydrogen that we make. So we sequester the carbon, and that hydrogen that's left has the carbon attributes of the tree residual in it.
Mm-hmm. Okay.
And so, there's all kinds of these calculations. We think we're about 150 megajoules per gram. I don't know if those are the right units. I'm too old to be doing those kind of units. We're a negative 150. Everybody will know what I mean. And,
compared to
zero at best for green hydrogen. So we're super negative because the tree did all that work.
Yeah. Okay. So the feedstock for this, it's different than the feedstock for blue hydrogen. That's gas that's coming from the oil and gas producing areas. Yeah. But that's not so with you're using wood. You talk about trees. It's not actually the whole trees. You're using...
We're using, scrap wood fiber is what we're using. And essentially when you cut down a forest in Canada, about half of the tree ends up being half of the wood that you harvest ends up being some kind of low value wood fiber. And the highest of the low value wood fibers is pulp. And the next highest is pellets, and the lowest is I leave it in the forest and burn it out there, and I call it slash. So those are all the same thing, just different categories of stuff. What we think ultimately at the end of this, 20 years from now, I believe we're a replacement for the pulp market. And the reason for that is I think the pulp market it's better to grow a pulp tree in Indonesia than it is here because it grows in 10 years and it takes 80 years to grow the same tree here. So over time, I think the pulp market, and I'm no wood guy, so now you're talking to an oil guy who's speculating on wood. And Brian Fair, my partner in this thing, he's a wood guy through and through. But what I believe is the market, there's way more margin selling wood fiber for its carbon attributes than selling it for its paper attributes. We think there's 3 times the margin. The wood fiber is 3 times as valuable when you're sequestering the carbon and putting it into one of the various tax regimes.
And this is not the high-value wood from those trees.
No,
It's the
we
lowest.
won't do anything with lumber. I mean, the lumber is going, that's why you harvest. But all this stuff, you have to do something with it. There's just too much of it. You couldn't burn it. There's just too much. So you're either, you're making it into something.
Now, you have a forest sector in Canada that faces various challenges.
Yeah.
We have wildfire and changing conditions. We have trade issues with the United States.
Yeah.
Are there any ways that your project could help relieve some of these issues?
Well, I think it's right on. I think it does help because the closer that market is to where the tree is growing, the better it is for every possible thing. There's more margin in it when I sell it. If I have a fire, I can put those fire burned trees in there because there's still a lot of carbon in those trees. They're mostly carbon. And so that material can go in this machine and convert it. And then we're not exposed to taxes imposed somewhere else. So when they have softwood lumber taxes, we're saying very interesting, but not for us.
We're making hydrogen out of wood waste. That waste would otherwise be left to rot and release CO2 gas into the atmosphere. So there's a benefit there, even before you get into creating hydrogen.
Yeah.
When we look at the potential for the fiber to be sourced in a way that creates other benefits, I know you've been doing some deals with First Nations communities.
We work with the Fort Nelson First Nation a lot. Chief Gale there has been a great supporter.
Charlene Gale, chief of the Fort Nelson First Nation.
She's helped us a lot. She understands what we're doing. I believe she supports it, and we think that'll be the first place where we get fiber from. Now we're building something that's big enough, so our plan is to build something that's using 4 million cubic meters of standing fiber a year. So that's a big demand anywhere. And we think ultimately we'll be able to easily get that in Canada, but not on day one. Right now, we've got enough, we think, for 3 phases. So the plant is built in sort of 4 identical copies, 4 trains, I call them, because I'm that kind of engineer. And each one uses about 1 million cubic meters of wet wood or about 500,000 cubic meters of pellets after they're dried.
Right. So you need a project that has got the full value chain seamlessly.
That's the way we approach it. So, one of my main, I'll call it a bitch because I don't know what else to call it. So people talk about people talk about taking carbon out of the air, but they don't talk about what they're going to do with it. They say, well, that's for somebody else. He'll do that. Or they talk about carbon sequestration, but they don't say where the carbon comes from. Who makes it? Is it pure? What specification is it? Those things are never dealt with. When we do something, we do cradle to grave. We have to know where the carbon goes, and we have to know where the hydrogen goes, and we have to know how to make it, and we have to be able to do everything because those other things are so risky. They condemn the project if we can't do them. So I'm old enough now. I get to work on the world scale. The only canvas I paint on is big, and I'm really interested in that. And I think I can change the world by doing this. But what it means is we can't leave this part of the job for somebody else. We got to do it ourselves.
So, to get from where we are now to having a thriving project with hydrogen being produced and being put to these uses, what needs to happen?
Well, we're after all levels of government. I don't want to say help us out. The federal government has put in different pieces of legislation, so they put in refundable investment tax credits for doing certain things. They put in carbon taxes on clean fuel standard, and that helps a lot. All of those things are things that are essential. A cost of carbon is essential to get this to work, and for the early copies, some kind of investment tax credit support is also essential to get it to work. The problem is no one looked at this as a system. They looked at it as you do this part and you get this. But when you look at the whole system, it's like if we sequester carbon and we make hydrogen, that's a problem. We think it should be a benefit. We're making hydrogen and we're going to decarbonize something else with that hydrogen. But the way the rules are written is if you make something else, it's a problem. And so what we're saying is, no, look at the system and say, what are you trying to achieve? I'm trying to achieve lower carbon intensity. I don't care where you get it. Just get it. And if you can prove you got it, we'll make sure that you fit.
It sounds like the rule book was maybe written before this technology came along. Is that a possibility? They just didn't think about it?
I think that's what it is. I think it just wasn't fully discovered and thought about well. And so we're trying to make them think, but it's, the horse got out of the barn a long time ago, so we're trying to catch him.
Yeah. It would be great if we could get this industry to come to BC because we need so many contributions, as many as we can get.
Well, BC's going to lead this. This is where
it's got the forestry base.
Yeah, so it's going to come from here, and that's why, and I haven't said enough about Brian and this thing.
Brian Fair.
Yeah,
from
Brian Fair.
Bid Group.
Yeah.
Yep.
So he's a great guy, and he's an old millwright, and I'm an old welder, so we get along really good. And it's rare I would say it in my life. Usually I'm mad at somebody. I never get mad at Brian, and he never gets mad at me that I can tell. Anyway, and we're both funding this thing because we believe in it, and it's important to him, and I'm learning from him every day. It's important. He's got really good relations with Indigenous people. He knows how, he's comfortable. I'm not. I've never been around much, and so I'm not comfortable. But what I believe is, I don't know anything about reconciliation, but I know if I create good jobs in the hinterland, that's going to do something for reconciliation, and that's what we're going to do. We think each phase of this thing creates 2,500 jobs in the forest, and so we think that's great. We think what we're making is going to be used around the world. We're not just making something for, a plant in Edmonton. We're making something for Nova Scotia, for southern BC, for Gulf Coast, and we think other people will come and buy these off us because our costs are coming down. Every time we make a copy, our costs come down. And pretty soon we'll be the most efficient guys in the block. And this is the size of a small car industry. This isn't the size of a refinery was a big job. We spent 50 million man-hours of labor at that refinery. This is not that. This is way bigger than that refinery was. I think we can spend $50 billion on this stuff by the time we're done.
When I was in your office a few years ago in Calgary, I noticed you had a big monitor up on the ceiling. You could see the Sturgeon refinery being built. It was a camera trained on the site there. It must have been quite something to watch that. I hope you get the chance to see this thing come together with one of those.
Yeah, I mean, these are the most fun that an engineer can have doing this stuff.
Yeah.
You get to build this stuff. You get to meet all the people. When I first started off, it was big enough we had to build it using union labor. And I think, oh, God, this is going to, guys like me, I never worked with a union before. This is going to be trouble. I get in there, they just want to build the thing. If you do your job right, they just want to build it. And we had so few problems. And at the end of it, the Boilermakers put me on the pension fund advisory committee because I'm such a good friend of theirs. They take me around with them. I'm like the tame owner. And I love working with them because we're all trying to do the same thing. We're trying to leave something decent behind.
The Boilermakers I know love to build things. So they're a perfect fit for you guys. I'm glad that this is working out. When you look at the future of hydrogen and carbon capture technologies, whether in Canada and globally, they seem to have their critics that say, well, you can't decarbonize with these technologies. Carbon capture doesn't work. You can't scale it. We've heard all the criticisms. What do you think of that, Ian?
I think it's just it's written by somebody who says, I wonder what all the possible things that could go wrong with something are. And if you took the same approach to an airplane, you'd never get on one. But you get on it every day and it works okay. And when's the last time one really broke? Not very often. This is the same thing. I mean, we've been putting carbon in the ground since the 70s in the States, and Pan-Canadian, did the Weyburn project. And I was significantly involved. I used to be 11% owner of the Weyburn project. That's been going on. They put 38 million tons of CO2 in the ground out there. It's like, that's a lot of CO2, any way you measure it. And every monitoring mechanism, every safety standard, everything else, it met every one of them. And it's been working and successful, and no one ever said anything about it. It's just going out there running away, right? And that's what the carbon trunk line is doing now. It's putting, every quarter we end up with another 1 million tons of CO2 in the ground, and no one's paying any attention to it. It's the biggest project in the world, and it's not that big a deal. Now, it's small relative. So the carbon trunk line project, I was looking it up on the internet, and I may get this number wrong, but I think it's right. It's equal to about 2/3 of all the passenger airline travel in Canada. That one project, the pipe is sized for 15 million tons. We haven't got 15 million going through it right now, but it'll eventually get there. That's 2/3 of all the passenger air traffic in Canada. That's like 3 guys in an office did that. So we can do these things in Canada because we've got 1.5% of the population, but we got 10% of all the stuff that we need to do this. So there's all kinds of things that we can do that nobody else can do as well. We just got to get going.
And there's a lot of trees.
Trees.
Plenty of those. So Ian, the Hydrogen Naturally project, that's the name of what you're driving here.
Yeah.
It's happening now. I was there a year ago, I think, in April of 2022 when you came to the Bayshore Inn in Vancouver, you and Brian Fair, and you announced with, I believe, Chief Gale, that you were going to be launching this project. That's a year ago now, and you're working on it. You're continuing to build this story. I'm really glad to see that it's going in the right direction.
Yeah.
I think that this is something, here's my opinion, since you didn't ask. You get it anyways. That right now it looks like we have some regulatory instruments that have been created in the saga of climate policy in British Columbia and Canada, going back to the mid-2000s, almost 20 years ago, which were fitted to the purpose of that moment. But maybe there are innovations that have happened since then where it would be a really smart idea for those people who are, in those jobs to take a look, especially at this one, because if we lose something this good, that would be, that would be too bad, wouldn't it? It'll show up somewhere else, and then it won't be a Canadian invention.
But I think any idea could sound good. The devil's in the detail, of course. But what I really believe is if the people running the system decide, I'm focusing on the result, I'm not focusing on the how. If you can make hydrogen cheaper with an electrolyzer, have at it. If you can make if you can make it a better way, cheaper with a lower carbon intensity, have at it. I don't care. I'll add up all the little bits and pieces and say, how much did you really do? Just measure the result. Tell them what you want. And then it'll be an amazing place because there's all these guys trying to figure out how to do something new all the time, and they'll figure out how to do that. If you tell them, no, this is the path we want you to follow, this is the preferred path, you'll end up like Russia. You just can't do that because the world is such a complicated place. You can't predict what the right answer is.
Describe the outcome and say, that's where we want to go.
Right.
Figure out how to get there.
Yeah. You guys figure it out. We'll reward you for figuring it out. That's it.
Yeah. There seems to be a tendency for that to work, as opposed to the...
And I think it'll happen. Like, I would say about the government, they're all listening to us. Like, we can get in and, they're talking to us. It's just the horse left the barn before we got there. So they're thinking, well, how do we catch the horse? But I believe that they're listening to us.
All right.
The other thing that I think we're really having trouble with is, and I'll say it here, is for some reason there's conceptual difficulty. If you use a machine to concentrate the carbon from 400 parts per million in the air up to 100%, the machine's okay, it all translates. If I use a tree and then I use a machine at the end of the tree to do exactly the same job, this machine doesn't count, that machine does count. I don't get that. That doesn't make sense to me, especially if you're leaving the tree behind or you're burning it or you're letting it rot. I don't get why you differentiate. Who cares where it came from? It's better this way.
Ian, this has been a fascinating discussion. I just want to throw one last question at you away from the minutia of hydrogen, which is an absolutely fascinating topic. Yeah. Just a bit of advice. You've been around a few decades now. You've built some big projects. What advice do you have for aspiring entrepreneurs and innovators who want to make a difference in the world of clean energy and carbon capture?
So the first thing, I'll give you 30 seconds on my history. So when I got out of university, I went to a job interview. My mom says, I'm going to the job interview. It was really important for my mom that I get a job. She says to me, if they offer you a job, you take it. They've got a good pension plan. So I'm in this meeting. I think this guy's an idiot. I'm never working for these guys. So I have to get out the door before he offers me a job because I got to tell Mom that I didn't get the job. So anyway, I didn't get the job. So when I started from that time working for myself, I never worked for anybody. I could weld okay, so I could always find work to do as a welder, and I turned that into a shop and made lots of stuff. So the first piece of advice I got is, if you're thinking about doing it, do it. Do it as fast as you can. There's all kinds of things that can go wrong. You're going to, if you wake up in the middle of the night worrying about something, where am I going to get food from? Don't worry, you'll get it from somewhere if you got the right attitude. Second thing is, it's not ideas. Don't fall in love with ideas. Think of these things as the world is such a complicated place. It has to be evolutionary. I can't know. It's unknowable if it's a good idea or not. But what I can know is the people I'm doing with this can adapt to uncertain, unknown, uncharted territory. That's who I need on the journey with me, and I have to be of that disposition myself. And people ask me what I do. I work on the edge of the earth. If it was a flat earth, I'm right on the edge. I fell off once. I haven't fallen off now for 35 years. There's really cheap opportunity on the edge of the earth. So think about what you're doing in the concept. I can own options on the future really cheap if I get out a couple iterations from where everybody else is. Don't read the newspaper and don't do all the stuff that is sexy. About 1 in 100 of those things ever works. Maybe it's 1 in 1,000, but it's like the odds are too tough in the place where the world's going. Out on the edge of the earth, things are simple.
Ian MacGregor, Executive Chairman of Hydrogen Naturally. Thanks for being part of the podcast today.
Thanks for having me. It's great.
Thank you for tuning in to the Eco Innovators podcast from ResourceWorks. Until next time, I'm your host, Stewart Muir. To stay updated on the latest in Canadian energy and natural resource innovations, connect with us on social media, including with me on Twitter at SJ Muir.